on. We've got just a little bit of time, so I think we can at least get some of the blood vessels lectures started. Probably won't get too far into it, if that's okay. As a heads up, there will be a significant number of pictures from this packet that you'll see on the exam. Probably, 15, 16 out of the 20 questions will be pictures. Because for the most part, what we'll be doing as we kind of can just scroll ahead is just coloring different blood vessels throughout the body, okay? These are the last structures of the cardiovascular system that we're going to talk about. They are going to contribute to homeostasis by providing the structures for the flow of blood to and from the heart, as well as the exchange of nutrients and waste in our tissues. They also play a role in adjusting the velocity or speed at which blood flows and the volume of blood, which relates to how much blood we have. Okay. Three main types of blood vessels include arteries, veins, and capillaries. Although your textbook includes two others, these are the truly three most overarching, I would say, types of blood vessels. And that's because the other two that they list, there's a small type of artery and there's a small type of vein, and that they classify as the other two. But arteries, veins, capillaries are the three big ones. Okay. Arteries are the efferent vessels of the cardiovascular system, which means that they are the blood vessels that take blood away from the heart. And as we just learned in our previous lecture, that blood is typically oxygenated, and that's why you see most of the time arteries are colored red. Whereas veins are the afferent vessels that carry blood towards the heart, and that blood is typically deoxygenated, and therefore that's why you see veins being typically colored blue. And in between arteries and veins are the microscopic thin-walled vessels, which we call capillaries. They are so small that we can't see them without a microscope, but that does not mean that they're not important, because they are actually where the magic truly happens, because they are the site of exchange. And this is where the oxygen can, travel through and or out of the heart or out of the blood vessel, and carbon dioxide and other ways can enter or leave the blood as well. So this is where we're doing exactly what exchange sounds like, moving stuff between the blood and surrounding tissues. Now, when it comes to arteries and veins, they are pretty similar in how they are built. They are both made up of three tunics or layers, and that's just fancier term for layer is the word tunic, which we see 3 times here. Okay. Whereas down here at the bottom, we see a capillary, which is a little bit different than the other two. Okay. We'll talk about those differences as we roll through. First layer that you find in both arteries and veins is the tunica interna, which you can also see described as an intima. I like interna because if you just add the letter L at the end of it, tells you exactly where it's at. It's the innermost part of the blood vessel. It's the inner lining of a blood vessel, and thus is in direct contact with the blood as it flows through what we call the lumen. The lumen is the space where the blood is at. Okay. It has actually a couple layers to it. The innermost layer is a layer of simple squamous epithelium called endothelium. And this is just continuous with what we find on the inside of the heart, where we describe it as endocardium. Okay, so that was one of the 3 heart layers. Endothelium, endocardium are no different structurally. They're both simple squamous. The only difference is endothelium is on the inside of a blood vessel, whereas endocardium is on the inside of the heart. Okay. Surrounding it is a basement membrane of loose connective tissue. Okay. And in arteries, there is a 3rd layer, but you don't find that 3rd layer in veins, what we call the internal elastic lamina, which is a sheet of elastic fibers with holes that make it look like Swiss cheese, which helps facilitate diffusion of materials. Okay. When we look at the picture at the bottom of a capillary, those major two layers of the tunica interna are here, the endothelium and its basement membrane, but we don't see any other layers, which makes capillaries extremely thin walled. And that's fantastic because the thinner their wall is, the easier it is for stuff to pass through them. Okay, looking over here on the right side of the page, we show zoom in of a capillary under a microscope 600 times. You can see actually the red blood cells inside of them, so you can really appreciate just how small they are, and you can just see just how thin the wall is in that capillary, especially when you compare it to veins and our thickest blood vessels, which are the arteries. And I really like this set of images on the right because it gives you a nice view of that difference in thickness and structural makeup. So those are the structures of the interna. The tunica media is the middle layer and is usually the thickest, consists primarily of smooth muscle. And the principal function of it is to mediate what we call vascular tone through processes of vasoconstriction and vasodilation. Vasoconstriction is what happens when the smooth muscle contracts, which is going to reduce blood flow through the lumen. This is like kinking a garden hose, and it basically kind of pinches the lumen shut, or at least, not 100%, closes it a little bit more than it was previously, so less blood flows through it. Whereas when that muscle relaxes, that produces vasodilation, which is going to increase the flow of the blood through the lumen. Now, those terms, vasoconstriction and vasodilation, truly relate specifically to arteries. Okay? And if you haven't noticed, arteries have a lot more muscle than veins do. Okay? And therefore, when we talk about veins contracting its muscle, it's not as drastic as a response as it would be in arteries. And so the actual constriction of a vein is called venoconstriction, whereas if it's dilated, we would call it venodilation, which is something that really is not as prominent as what we see in arteries. Okay? Now, there's another layer that's part of the tunica media, but you only find it in arteries. It's another one of those Swiss cheese layers. We call this the external elastic lamina. It just helps separate the media from the externa. And speaking of the externa, it's the outermost layer of your blood vessels, found both in arteries and veins. Consists of elastic and collagen fibers. Your biggest arteries and veins are actually going to have small little blood vessels in this area, or in this layer, called vasa vasorum, or vessels to the vessels. Okay, they are like the coronary arteries and veins that we just talked about that are supplying the heart. Okay, same situation where the blood's on the inside of these blood vessels, nutrients are maybe not going to be able to come out and to provide nutrients and provide waste or remove waste from the externa. So they actually have their own blood vessels. And not all blood vessels are going to have their own tinier blood vessels, but your bigger ones absolutely should. Overall, the function of the externa is just to help anchor the vessels to surrounding tissues. And now, as I've kind of mentioned, there are some differences between arteries and veins. Okay, well, I've mentioned more smooth muscle is in arteries. There's a couple other layers in arteries. And for that reason, as you can see, and definitely get a view of it here, arteries are much, much thicker than veins. Okay. That affects the size of the lumen of an artery versus a vein. The space where the blood is flowing is much larger in veins than it is in arteries. And therefore, veins can actually hold a lot more blood. And rest, like in a state where you're sitting around listening to me talk, over half your blood is found in your veins. And it's actually like 65% or so. Now, there's one big difference that I haven't touched on between arteries and veins. Anybody see it? Veins have something that arteries don't. Valves. And these valves are like the valves in your heart, and that they're going to prevent blood from going backwards. And these are especially very important, like in our legs, which prevents blood from just like staying down in your feet, because blood inside our body is affected by gravity, just like blood outside the body, or any other fluid outside the body, where gravity wants to push it down towards the ground. And like if you're standing up, it would be natural tendency of blood to stay in your feet, but we don't want that to happen at all. As far as those three images on the left, I do actually want you to identify those different things. So make sure you know those and identify them. And make sure you can identify which one's an artery, which one's a vein, and which is a capillary as well. Okay, what we're going to do on Tuesday is just pick up and talk more about arteries and the different types of those, and then we'll do the same thing for capillaries and veins before we actually start getting into identification and whatnot. So got a little more background information to cover, but we'll start that next week. So I will set you free. Don't forget that you do have